Hi guys, welcome again to Pathology in a nutshell. My name remains Dr. Ben, and today we are going to be talking about inflammation. In our last set of videos, we looked at cell injury, the causes of cell injury, and we also talked about cell death. Inflammation is actually the body's mechanism to fight and eliminate these offending agents. Sometimes when we hear inflammation, we usually think of a harmful reaction, but actually, inflammation is a protective mechanism that the body has put in place to ensure that these offending agents or these sources of cell injury are removed. Therefore, inflammation is defined as the response of a living vascularized tissue to injury that serves to recruit leukocytes and mediators of inflammation to the site of injury in order to eliminate the offending agent. Okay, so we'll take that again. It is the response, inflammation is a response of a living, it has to be living, dead things don't respond, living vascularized tissue, okay? Vascularized, meaning that it must be supplied by blood vessels. It must have blood vessels. Vascularized tissue is a response of a living vascularized tissue to injury. That is basically what inflammation is. And the purpose of inflammation is so that leukocytes, okay, and mediators of inflammation can be carried to the site of injury. Okay, they are carried to the site of injury for the purpose of eliminating the offending agent. Now that is basically what inflammation is all about. And every time inflammation is stimulated or the inflammatory response is stimulated, it is aimed at ensuring that these leukocytes, that's cells of inflammation and mediators of inflammation, are carried, okay, in the blood to the site of injury. And the whole idea is so that they can eliminate the offending agent. Now, inflammation can be acute. Inflammation can be acute, okay, or it can be chronic. Okay. Usually, acute inflammation is usually of shorter duration. Okay, shorter duration. It starts within seconds to minutes. Okay, and sometimes it can last a few days, and is usually in response to some bacteria, fungi. Okay, yes. While chronic inflammation is actually an inflammation that is of longer duration. It can last for up to months and even years. Okay, and it usually is a response to tough organisms. Let's use that word. Very tough organisms. Some bacteria are quite tough, like tuberculosis. Okay, it can be a response to foreign bodies. Okay, and it can also be as a result of immune reactions. Okay, now those are the two kinds of inflammation that we have. Now, inflammation generally follows what we call the process of inflammation generally follows what we call the 5 R's. The 5 R's. Okay, the first thing is that these offending agents must be recognized. They must be recognized. Okay, the second is that inflammatory cells and mediators must be recruited. Okay, so there's recognition, there's recruitment, And after they are recruited, of course, they will remove the offending agent. So there's removal. And because inflammation is quite a very sensitive reaction, it must be regulated so that it will come to an end when its purpose, when it has served its purpose, when it is no longer needed. Okay, so there's what we call regulation. And finally, the fifth R is what we call repair. Okay, inflammation can also damage host tissue. Okay, and so because of that, it repairs both the collateral damage that it has caused and even the damage that the offending agent may have caused. So inflammation initiates the process of repair. So these are the five processes through which inflammation goes through. And we will talk very powerfully about recognition, because for offending agents to be recognized, there has to be receptors. There has to be certain receptors, okay, that will help with the recognition of offending agents. So let us talk about recognition receptors. So yes, let's talk about recognition receptors. Okay, like I began to say, for the body to mount a response against an offending agent, that offending agent must be recognized. And there are receptors on several cells in the body, sentinel cells and inflammatory cells alike. They have receptors that help to recognize these offending agents or even products of tissue damage. Okay, and these receptors have been called pattern recognition receptors. Pattern recognition receptors. That's PARs. Okay, and they are called pattern recognition receptors because they recognize mainly patterns on microbial agents and patterns also on or patterns that show evidence of cell injury or cell damage. Okay, and there are two major pattern recognition receptors that these cells, these sentinel cells, and these inflammatory cells have, and they are called. The first one is called the toll-like receptors. Toll-like receptors. Okay, which we call the TLRs. Okay, now toll-like receptors recognize mainly pathogens. Okay, they recognize pathogens, and those portions of the pathogens that they recognize, like I said, they recognize patterns, are known as pathogen associated molecular patterns. Molecular patterns. Okay, that's PAMPs. Okay, pathogen associated molecular patterns. That is what the toll-like receptors recognize. These toll-like receptors are usually found on sentinel cells, epithelial cells. They are also found on the inflammatory cells themselves. They are found on mast cells, basically sentinel cells of the body. Okay, they recognize pathogens. Okay, now the other set of receptors that are pattern recognition receptors are known as the node-like receptors. Node-like receptors. Okay, and these node-like receptors actually recognize evidence of tissue damage. And so those patterns that give an evidence of tissue damage are known as damage-associated molecular patterns. Damage-associated molecular patterns. Okay, DAMPs. Okay, and what are examples of damage-associated molecular patterns? I believe in one of our videos, we began to mention them. Examples include ATP. We talked about ATP. We talked about uric acid. Uric acid. We talked about DNA itself. Okay, these are products of that are supposed to be within the cell, but by the time they begin to come out and leak out of the cell, of course, the body notices that something is wrong. And then we also talked about changing concentrations of potassium ion. So these are the major damage-associated molecular patterns that the node-like receptors recognize. So when there is tissue injury and these things are exposed, okay, these receptors on sentinel cells and on inflammatory cells recognize this and, of course, stimulate the inflammatory response to seek out what may be the cause of that tissue damage. Of course, there are other receptors. There are other receptors that play significant roles in inflammation. For example, the mannose binding lectin, which recognizes mannose sugars on microorganisms. Okay, mannose binding lectins. Okay, we have receptors for complement system, complement receptors that recognize complement. Complements are also mediators of inflammation, plasma proteins that help with the inflammatory response. So we have complement receptors, okay, that are also important in inflammation. Okay, we also have G protein coupled receptors, G protein receptors. G protein receptors that help with the recognition of certain mediators of inflammation. So these are some of the receptors that play a role in inflammation. Okay, now we will talk about the features of inflammation. So what are those features? What are those features of inflammation? The first one are the components of inflammation. The components of inflammation. The major components of inflammation are blood vessels, inflammatory cells, and of course, the mediators, okay, the mediators of inflammation, the chemical mediators of inflammation, okay. So when inflammation is to begin, blood vessels respond because these inflammatory cells and a lot of these mediators of inflammation are within blood vessels. And so these blood vessels must respond so that the inflammatory cells and the mediators can get to the site of injury and begin their function. Another feature of inflammation is that inflammation can be harmful. Inflammation can be harmful, okay? Inflammation has harmful effects. Inflammation has harmful effects. Okay, usually inflammation is expected to be directed, okay, towards where injury is, and of course to ensure that the offending agent is eliminated. In the process, sometimes there may be collateral damage where surrounding tissues may also be injured as a result of the inflammatory response. That is part of what happens in inflammation. And usually, those are the sources of some of the signs and symptoms that we see when inflammatory processes are going on. But other times, inflammation can be misdirected. Okay, when inflammation is misdirected, it can lead to what is called hypersensitivity reaction. Hypersensitivity, in which case there's an exaggerated immune response to a noxious stimuli, or sometimes there's an exaggerated immune response to a substance that should normally not stimulate the immune system. That is what hypersensitivity is. Sometimes it can also be an autoimmune problem, in which case inflammatory cells or the inflammatory mechanism is directed against host tissue. Is directed against host tissue. Is directed against host tissue, and of course, that can lead to injury. Okay, now we had already talked about the fact that inflammation can either be acute, okay, or it can be chronic. It can either be acute or it can be chronic. And in some cases, like in ulcers, we may see chronic inflammation having a superimposed acute inflammation, which we call acute on chronic inflammation. Inflammation also have systemic effects, okay, systemic effects, okay? And so sometimes when there are inflammation, apart from the local effects that we see at that site of injury, there may be evidence of systemic effects. And such systemic effects include the development of fever, okay, leukocytosis, that's increase in the number of white blood cells, okay. When we do a full blood count, we see leukocytosis, okay. There may be also an increase in some acute phase reactants, acute phase proteins. Okay, acute phase proteins are proteins that are altered as a result of inflammation. Sometimes they can be positive and then there can be negative acute phase proteins. Okay, so these are some of the systemic effects of inflammation. And these are the features or the characteristics of inflammation. The next thing we want to look at is just talk briefly about the historical perspective of inflammation. So there are certain interesting things about the history of inflammation. Of course, we didn't get where we are today by accident. Okay, things happened over time that eventually led us to what we know today about inflammation. And do you know that inflammation has been documented in Egyptian papyrus? In the Egyptian papyrus, since 3000 years BC. Okay, so there have always been a knowledge that there is such a thing as inflammation. Okay, and Celsius, a Roman writer, in the first century AD, documented the 4 cardinal signs of inflammation. Okay, where he talked about rubor, okay, which is redness. Talked about calor, which is heat. Talked about tumor, which is swelling. And he talked about dolor, which is pain. And these are actually the 4 cardinal signs of acute inflammation. The 4 cardinal signs of acute inflammation. In the 19th century, Rudolf Virchow, the father of modern pathology, okay, added a 5th cardinal sign, which is functio lasae. Meaning loss of function. It was John Hunter who told us that inflammation is not necessarily harmful, is not necessarily a harmful effect, okay, but it is a protective mechanism, okay, against infections or against offending agents. Now, Eli Metnikov, please pardon me if I don't get the spelling. Eli Metnikov was the one who told us about phagocytosis. Phagocytosis. After observing leukocytes phagocytosing bacteria, he said that phagocytosis is the whole aim of inflammation because, of course, those cells are to be carried, and the major way by which they eliminate these offending agents is by phagocytosis, and it was told to us by Eli Metnikov. Now, the mediators of inflammation, the concept of the mediators of inflammation came to us through Sir Thomas Lewis. Sir Thomas Lewis. After he observed that a substance which we now know to be histamine, okay, induced vasodilatation and increased vascular permeability during inflammation, okay. So these were the founding fathers, so to speak, with respect to how the body responds to injury. And of course, as time have continued to go on, we have continued to see and evolutions are happening with respect to knowledge on the issue of inflammation. In our next video, we will be talking about acute inflammation in details. I hope this summary or this overview made sense to you. Please like, okay? I would like to hear feedbacks. I would like to hear your comments, okay? And also share so that others can subscribe. Thank you so much. See you in the next one.